In the spring of 1823, in the basement archive of the Royal Society in London, a junior cataloguer named Edmund Vane found something that contradicted the official meteorological record. The inventory described the crate as storm observations, routine, Devon parishes, 1810 to 1815. Yet the documents inside bore dates that did not align. Rain gauges calibrated for water showed measurements taken in something else. Soil samples sealed in glass vials, each labeled with a city name and a single year, 1812. The handwriting varied. English, French, German, Russian, but the year remained constant. Outside, time equals 350 milliseconds, March. Rain tapped against the narrow window set high in the stone wall, and dust moved through the shaft of gray light like slow smoke. Vane opened the first vial. The substance inside was not earth in any conventional sense. It held no smell of loam or clay. Under lamplight, it appeared uniform, silty, faintly metallic. A notation in pencil on the label read, Moscow, September, depth 4 inches, origin unknown. The official chronicles of 1812 describe a year of war. Napoleon's Grand Armée marched into Russia. Battles raged across Europe. Fires consumed Moscow. Yet woven through military dispatches and casualty lists, time equals 450 milliseconds / another record emerges, fragmentary, often dismissed, rarely correlated. Parish registers note great rains of mud. Civic ledgers document sudden expenditures for street cleaning in months previously recorded as dry. Personal letters describe mornings when the ground was covered in a fine gray sediment that had not been there the night before. No storms preceded it, no floods explained it. The mud simply appeared. By autumn of 1812, reports surfaced from cities across the Northern Hemisphere. In Philadelphia, a clerk at the Office of City Works recorded an entry dated 14th October. Streets fouled with unknown silt, no rain previous. Fortnight. In Vienna, municipal records from 3rd November described gray deposit on cobblestones, removed at considerable expense. In St. Petersburg, a marginal note in a quartermaster's log mentions sediment covering parade grounds, origin unclear. The distances between these cities measured in thousands of miles. The timing, however, clustered within weeks. The phenomenon was not isolated to capitals or ports. Smaller towns reported the same occurrence. In the Bavarian town of Landshut, church records from October 1812 include a curious annotation. Mud on church steps, no storm recorded. In the English village of Whitby, a fisherman's diary. Entry from 29 September notes, queer silt on the pier at dawn, tide had been out all night. In the Russian city of Kazan, an administrative document dated 18th October describes fine dust covering Market Square, dry weather continues. The substance itself resisted easy classification. Those who examined it, physicians, natural philosophers, mineralogists, offered conflicting assessments. Some described it as volcanic ash, though no eruptions had been reported. Others suggested it was river silt carried by unprecedented winds. Yet the material appeared in landlocked cities far from any waterway. A few noted its uniformity, the way it seemed refined, almost processed, lacking the organic matter typically found in soil. In a letter dated 12 November 1812, a French chemist in Lyon wrote to a colleague, "The sample you sent defies analysis. It contains iron, but not as ore, silica, but not as sand. The particles are extraordinarily fine, finer than any natural sediment I have examined. It is as if the earth itself had been reduced to powder." Official responses varied. In some cities, authorities ordered immediate removal, treating the mud as a nuisance or potential health hazard. In others, it was ignored, allowed to wash away with the next rain. Time equals 350 milliseconds, or be trampled into the streets. Few governments acknowledged a connection between reports from different regions. Communication across Europe remained disrupted by ongoing conflict. Information traveled slowly, and by the time patterns might have emerged, the material had largely disappeared. Yet the archives preserved traces. In the Bibliothèque Nationale in Paris, a folio labeled Correspondance Scientifique 1812 contains letters from natural philosophers across France describing identical observations. A physician in Marseille, writing on the 7th of October, mentions a fine gray powder covering the harbor district. A botanist in Strasbourg in a letter dated the 22nd of October, time equals 400 milliseconds describes sediment on garden beds, detrimental to autumn plantings. A military engineer in Toulouse reports, on 1st November, unusual deposits on fortification walls, composition unknown. The letters share no reference to each other, suggesting independent observations of the same phenomenon. Across the Atlantic, American records echo these accounts. In Boston, the diary of a merchant dated 19th October 1812 includes this entry: "Woke to find the courtyard covered in a thin layer of gray matter. No rain in 3 days. Servants cannot explain it." In New York, a municipal ledger from late October notes expenses for removal of foreign sediment from public squares. In Charleston, a planter's journal from 2nd November describes ash-like substance on fields, not from any fire. The timing suggests a pattern. Most reports cluster between late September and early November 1812. A few earlier instances appear, one from Madrid in August, another from Copenhagen in mid-September, but the majority fall within a 6-week window. After November, mentions diminish. By December, they cease almost entirely. The substance either stopped appearing or ceased to be recorded. Contemporary explanations reflected the scientific understanding of the era. Some attributed the mud to distant volcanic eruptions, though no significant volcanic activity was documented in 1812. Mount Tambora would not erupt until 1815, producing the year without a summer in 1816, a well-documented climatic event. The 1812 deposits left no comparable mark on climate records, suggesting a different origin. Others proposed atmospheric phenomena, unusual wind patterns carrying dust across continents. But meteorological observations from the period show no evidence of storms severe enough to achieve such distribution. A third explanation, rarely voiced in official documents but present in private correspondence, suggested something else entirely. In a letter dated 3rd December 1812, housed in the archives of the University of Göttingen, a professor of natural philosophy writes, "I have examined samples from 4 cities. The consistency is remarkable. This is not the random distribution of natural forces. There is uniformity here, a precision that suggests intent or mechanism beyond my comprehension." The word mechanism appears again in other documents. A Russian academician, writing in early 1813, uses the term to describe the regularity of the deposits. A Scottish engineer, examining samples collected from Edinburgh, notes, "The even distribution, as if applied by machinery." The concept sits uneasily in the context of 1812. Industrialization had begun, but nothing existed that could distribute material across such distances with such uniformity. On 17th February 1825, in the private library of a country estate in Sussex, a collector of curiosities named Sir Horace Blackwell examined a set of sealed glass vials he had acquired from the estate sale of a deceased chemist. Each vial contained a small quantity of gray powder. The labels, written in a careful hand, listed cities: Berlin, Naples, Warsaw, Stockholm. All bore the year 1812. Blackwell, an amateur geologist, subjected the samples to the analytical methods of his time. He dissolved portions in various acids, heated them, exposed them to magnetic fields. His notes, preserved in the British Library, describe results that perplexed him. The material resists decomposition. It shows no organic content. Under magnification, the particles appear uniform in size, unlike any natural sediment. Most curious, when heated to high temperature, the powder fuses into a glass-like substance with a faint metallic sheen. By the mid-19th century, the 1812 mud had become a footnote, if remembered at all. Scientific journals occasionally mentioned it in passing, usually in discussions of unusual atmospheric phenomena. A treatise on meteorology, published in 1847, includes a brief paragraph: "The anomalous deposits of 1812 remain unexplained. Various hypotheses have been proposed, none entirely satisfactory. The matter merits further investigation, though primary sources are scarce." The scarcity of sources is itself notable. Many records from 1812 focus on war. Napoleon's campaign dominated documentation. Civic and ecclesiastical records that might have noted unusual events often prioritize military movements, requisitions, casualties, mundane observations. Odd weather, strange deposits, received less attention, or were omitted entirely. What remains are fragments: a line in a ledger, a sentence in a diary, a marginal note in a letter. In 1889, in Vienna, a historian named Franz Weigel published a monograph on urban administration during the Napoleonic Wars. One chapter, titled Civic Maintenance and Unusual Expenditures, examines municipal budgets from various European cities between 1810 and 1815. Weigel noted a spike in street cleaning costs in the autumn of 1812 across multiple cities. He cross-referenced these with weather records and found no corresponding increase in rainfall or storms. He concluded, some event occurred in the autumn of 1812 that required extraordinary efforts to clean public spaces. The nature of this event is not recorded in official documents, but the financial evidence suggests it was widespread and simultaneous. Weigel's work went largely unnoticed. Published in German, it circulated among a small academic audience. No subsequent historian picked up the thread. The 1812 mud remained a minor mystery, overshadowed by the dramatic events of the era. On 6 July 1923, in Moscow, an archivist sorting through documents relocated during the Russian Revolution found a bundle of papers labeled St. Petersburg Municipal Administration, 1812. Among routine reports, street maintenance, market regulations, sanitation orders, she discovered a memorandum dated 21 October 1812. It described an unusual atmospheric deposit covering the city's central districts. The memorandum ordered immediate removal and analysis. A follow-up report, dated 4th November, stated, "Analysis incomplete, substance unlike known soils. Recommend preservation of samples for further study." No further documents in the bundle mentioned the matter. The archivist, intrigued, searched for related materials. She found references in records from other Russian cities, Kazan, Novgorod, Smolensk. Each described similar deposits in October or early November 1812. Each noted the unusual nature of the material. None offered an explanation. The archivist compiled her findings into a brief report submitted to the Soviet Academy of Sciences. The report, filed and forgotten, resurfaced decades later in a different context. In the winter of 1956, in Leningrad, a geologist named Dmitry Sokolov was researching historical dust storms for a study on soil erosion. He came across the 1923 report in the Academy's archives. Curious, he requested the original documents from St. Petersburg. Most had been lost or destroyed, but a few samples survived. Small vials of grayish powder stored in a wooden box. Sokolov subjected them to modern analysis. His notes, dated 14th March 1956, record his surprise. The material contains elements not commonly found together in natural sediments. There is aluminum oxide, silicon dioxide, iron oxide, but in proportions that do not match any soil type in European Russia. More puzzling, the particle size distribution is extraordinarily narrow. Natural sediments show a range of particle sizes. This material is almost monodisperse, as if it had been sieved or processed. Sokolov's findings raised more questions than they answered. He attempted to trace the material's origin but found no geological source that matched its composition. He considered industrial pollution, but heavy industry in 1812 lacked the scale or technology to produce such refined particulates, let alone distribute them across hundreds of miles. He drafted a paper for publication, but ultimately withdrew it, citing insufficient evidence for his conclusions. The samples remained in the Leningrad archives, catalogued but unstudied. In 1978, during a reorganization, they were transferred to the Institute of Geology. A new generation of researchers, equipped with more advanced analytical tools, examined them again. Electron microscopy revealed that the particles were not only uniform in size, but also in shape, almost spherical, with smooth surfaces. This degree of uniformity suggested a process, not a natural formation. One researcher, in a memo dated 9 August 1978, wrote, "These particles resemble those produced by high-temperature combustion or industrial processes. However, no such processes existed in 1812. The implications are disturbing." The memo went no further. The Soviet scientific establishment, focused on practical applications and state-directed research, had little interest in historical anomalies. The 1812 mud was filed away again, this time in a category labeled Unexplained Phenomena. low priority. Across the Atlantic, similar patterns emerged. In 1961, a graduate student at Yale University, researching early American industrial history, stumbled upon references to the 1812 deposits in New England municipal records. Intrigued, he collected samples from historical societies and museums, a few vials preserved by 19th century naturalists. Analysis showed the same characteristics: fine, uniform particles, unusual composition, no clear natural source. He mentioned his findings in his dissertation, but the topic was peripheral to his main research. The dissertation was filed, read by a handful of scholars, and forgotten. In the late 1990s, with the advent of the internet, disparate researchers began connecting dots. A historian in France, time equals 350 milliseconds studying Napoleonic-era correspondence, posted a query on an academic forum about the 1812 mud. A geologist in Russia, familiar with Sokolov's work, responded. An American archivist, aware of the New England samples, joined the discussion. For the first time, individuals across continents compared notes. They discovered that reports of the 1812 deposits existed in archives from at least 200 cities. The distribution was global: Europe, North America, parts of Asia. The timing was consistent, late September through early November. The material's characteristics matched across samples: fine, uniform, metallic gray particles, time equals 400 milliseconds / greater than, with an unusual composition. Yet no contemporary account acknowledged a connection between these observations. Each city seemed to record the phenomenon in isolation, unaware that others experienced the same thing. On the 22nd of September, 2003, in a basement laboratory at the University of Edinburgh, a team of researchers analyzed one of the oldest surviving samples, a vial from the Royal Society collection, the same collection Edmund Vane had catalogued in 1823. Using mass spectrometry and isotopic analysis, they determined that the material contained trace elements not found in terrestrial soils. The isotopic ratios suggested high-temperature formation, possibly in an oxygen-poor environment. One researcher, Dr. Helen McLeod, summarized the findings in her notes. This material was not formed by any natural geological process known to occur on Earth's surface. Its origin remains unexplained. The team published their results in a specialized journal. The paper generated mild interest among geologists and historians, but failed to penetrate mainstream awareness. The mystery of the 1812 mud remained confined to academic circles, a curiosity rather than a crisis. Yet questions persisted. If the material was not natural, what created it? If it appeared simultaneously in 200 cities, what mechanism distributed it? And perhaps most unsettling, why did contemporary authorities not investigate more thoroughly? The record suggests that officials in various cities noted the deposits. Some even conducted analyses, but no coordinated effort emerged to understand the phenomenon on a global scale. Communication networks in 1812, though slower than today, were sufficient for major events to be recognized across continents. Wars, famines, epidemics, all were documented and discussed internationally. Why not this? One possible answer lies in the nature of the phenomenon itself. The deposits were brief, ephemeral. They caused no immediate harm, no dramatic disruption. Within weeks, rain and human activity had washed or trampled the material away. Unlike a volcanic eruption or a meteor strike, which left permanent marks on the landscape, the 1812 mud vanished almost as quickly as it appeared. By the time anyone might have coordinated a broader investigation, the evidence was gone. Another possibility is that the deposits were simply overshadowed by more pressing concerns. The year 1812 was tumultuous. Europe was at war, resources were strained, governments focused on survival, not scientific inquiry. A strange sediment on the streets, however puzzling, did not warrant attention when armies were marching and cities were burning. Yet this explanation feels incomplete. The archives contain evidence that some individuals recognize the phenomenon's significance. Letters, notes, memoranda, scattered across institutions, suggest that observers sensed something unusual, something that merited documentation. Why, then, did their concerns not coalesce into action? In December 2011, a researcher named Oliver Voss, working in the archives of the Humboldt University in Berlin, found a bound volume labeled Correspondence, Naturphilosophie, 1812 to 1815. Inside were letters exchanged between natural philosophers across German-speaking regions. One letter, dated 8th November 1812, caught his attention. Time equals 600 milliseconds / written by a scholar in Leipzig to a colleague in Munich. It described the gray deposits and included a striking observation. I have corresponded with acquaintances in Hamburg, Dresden, and Vienna. All report the same. I begin to suspect this is not a local matter. Something has occurred on a scale beyond our comprehension. The letter continued. I propose we collect samples and testimonies. If we act swiftly, we may yet understand this event. However, I fear the chaos of war will obscure our efforts. Already, correspondence is delayed, routes are unsafe, and attention is diverted. If we do not act now, this mystery will be lost to history. The subsequent letter in the volume, dated 2 months later, made no mention of the deposits. The topic had been abandoned, consumed by more immediate concerns. Voss published his findings in a German historical journal in 2013. The article titled Die Schlammbelagerungen von 1812, eine vergessene Anomalie, compiled evidence from archives across Europe. It noted the global distribution, the uniform characteristics, the lack of explanation. It concluded, the 1812 deposits remain one of the least studied and most enigmatic events of the 19th century. Modern analysis suggests a non-natural origin. Time equals 500 milliseconds / greater than yet. No mechanism can be proposed within the bounds of known science. The article was read by a small audience. A few historians expressed interest. A geologist in Sweden wrote a response, offering alternative hypotheses, perhaps a previously unrecorded meteor airburst that dispersed fine debris, or an unknown volcanic eruption in a remote region. But these explanations struggled to account for the material's unusual composition and the precision of its distribution. On 11th April 2017, in a conference room at the Massachusetts Institute of Technology, a symposium on historical anomalies brought together researchers from various disciplines. One session focused on the 1812 mud. Presentations reviewed the evidence, the widespread reports, the uniform material, the lack of contemporary explanation, the modern analyses. Debate followed. Atmospheric scientists proposed meteorological mechanisms, unusual jet stream patterns, unprecedented dust storms, but acknowledged these were speculative. Geologists reiterated the material's non-terrestrial characteristics. Historians noted the curious silence in official records. One participant, a physicist specializing in aerosols, offered an observation. If we encountered this phenomenon today, we would attribute it to industrial pollution or atmospheric testing. But in 1812, no such sources existed. Time equals 600 milliseconds. We are left with a substance that resembles industrial byproduct, appearing in an era that lacked industry capable of producing it. The symposium ended without consensus. The 1812 mud remained unexplained. In the years since, a few researchers have continued to investigate. They have examined additional samples, cross-referenced more archives, applied newer analytical techniques. Each study confirms the previous findings. The material is real, widespread, and anomalous. Yet no explanation has gained broad acceptance. Some have proposed that the deposits were the result of a natural event so rare that it has not recurred in recorded history, a unique conjunction of atmospheric and geological forces. Others suggest that the evidence is incomplete, that key documents or samples have been lost, and that with more data, a conventional explanation would emerge. A few, more speculative voices hint at possibilities beyond current scientific frameworks, though these ideas remain on the fringes, unsupported by rigorous evidence. What remains undisputed is the historical record itself. In the autumn of 1812, approximately 200 cities across the Northern Hemisphere experienced the sudden appearance of a fine, gray, uniform sediment. It arrived without warning, defied contemporary understanding, and vanished within weeks. Those who examined it found it unlike any known soil. Those who noted it often did so in passing, treating it as a curiosity rather than a crisis. And history, preoccupied with war and upheaval, largely forgot it. On 8 October 2019, in a modern air quality monitoring station in Brussels, a technician reviewed overnight data. Sensors designed to detect particulate pollution had registered an anomaly around 3 a.m., a brief spike in fine particles, lasting less than an hour. The composition was unusual, high in aluminum and silicon oxides, with trace metals. The source could not be identified. By morning, the particles had dispersed, diluted, into the urban atmosphere. The technician filed a routine report. It noted the anomaly, suggested possible sources, construction dust, industrial emission, and recommended no further action. Similar reports, buried in environmental monitoring databases across Europe and North America, occasionally record unexplained spikes in fine particulates. Most are attributed to known sources. A few remain unclassified. The modern world produces vast quantities of airborne particles, industrial emissions, vehicle exhaust, construction dust. Anomalies blend into the background, indistinguishable unless one knows what to look for. If the 1812 mud appeared today, time equals 450 milliseconds greater than it might go unnoticed. Our atmosphere is already filled with particulates. Sensors would detect it, but it would be one data point among millions. Unless someone examined the composition closely, unless they recognized the pattern, it might simply be recorded, filed, and forgotten. Yet in 1812, the air was clearer, cities were smaller, industry was nascent. When something unusual appeared, it stood out. People noticed. Some recorded it. A few tried to understand it. They did not succeed, but they left traces. Fragments of observations scattered across archives, waiting for someone to piece them together. The question remains, what happened in the autumn of 1812? What process, natural or otherwise, could distribute a uniform material across 200 cities simultaneously? And perhaps more unsettling, if it happened once, could it happen again? The archives offer no answers, only evidence. The mud was real. The reports are consistent. The material defies easy explanation. History records the event but does not interpret it. We are left with what Edmund Vane found in 1823, sealed vials, dated labels, and a single notation. Origin unknown. Today, the few surviving samples reside in museums and university collections, catalogued under various headings. Historical geological samples, 19th century curiosities, unexplained deposits. Researchers occasionally request access, conduct new analyses, add a few more data points to the accumulating evidence. The picture grows sharper, but the mystery does not resolve. In the end, the 1812 mud remains what it has always been, a moment when the ordinary order of things was briefly interrupted. For a few weeks in autumn, something happened that should not have been possible. The world noticed, shrugged, and moved on. The mud vanished, but the question lingers. In the silence of archives, in the sealed vials gathering dust, the anomaly waits, unexplained, unresolved, and impossible to ignore once you know it exists. If history is written by survivors, perhaps anomalies are written by witnesses. And the witnesses of 1812, though they could not explain what they saw, ensured it would not be entirely forgotten. They wrote it down. They preserved samples. They left a trail of evidence for those who would come later. Whether we, with our advanced tools and broader perspective, can decipher what they recorded remains to be seen. The mud appeared, the mud vanished, the mystery endures.